Why do proportional operational amplifier circuits need to add balance resistors? This is an inverting proportional operational amplifier circuit. The output voltage is equal to negative RF divided by R1 times VIN. This is a non-inverting proportional operational amplifier circuit. The output voltage is equal to 1 plus RF divided by R1 times VIN. You can see that there is a resistor R2 in both circuits. The inverting proportional operational amplifier circuit is placed from the non-inverting end to ground. The non-inverting proportional operational amplifier circuit is placed between the input signal and the non-inverting end. Resistor R2 is generally called a balance resistor or compensation resistor, and its resistance value is equal to the parallel value of R1 and RF. For an ideal operational amplifier, the input resistance is infinite and no current flows into the input of the operational amplifier. However, in reality, the input part of the operational amplifier is generally a transistor or a field effect transistor, FET. For an operational amplifier with a transistor input, a certain bias current is required for the transistor to work in the amplification zone. For an operational amplifier, the current is generally at the null level. For an operational amplifier with a FET input, there will be a certain leakage current, which is generally at the PA level. The input bias current IB of the operational amplifier is equal to 1/2 of IP plus IN. For an inverting proportional operational amplifier circuit, if you calculate the effects of IP and IN on the output voltage separately, short-circuiting the input signal at this time can obtain the output voltage generated by IP and IN. Delta VO equals IN times RF minus IP times R2 times 1 plus RF divided by R1. Generally, the bias currents of the non-inverting and inverting ends of an operational amplifier are equal. We remember that IP equals IN equals IB, and the formula can be simplified into this one. When R2 equals R1 in parallel with RF, delta VO equals 0. At this time, the output voltage caused by the input bias current of the operational amplifier is 0. Therefore, for a proportional operational amplifier circuit, the function of a balance resistor is to eliminate the influence of input bias current on output voltage. Generally speaking, due to the fact that it is impossible for input-level devices to be exactly the same, there will be differences between them. The difference between these two values is called the input offset current of an operational amplifier and is represented by IOS. IOS is generally smaller than IB, so even if a balance resistor is introduced, bias current will still generate a certain output voltage. Since IOS is very small, generally at null level, so the output voltage generated by input bias current is very small. In most cases, such errors can be ignored. However, for occasions where very weak signals need to be amplified, such as when signals themselves are at UV level, at this time errors caused by input bias current cannot be ignored and therefore need to be selected with smaller precision amplifiers with smaller input bias currents and offset voltages.